Welcome and thank you for joining us here on Stream 2 at DSC MENA 2025. And my name is Shahad, and I'll be your host through today existing sessions. Uh, up next is Ahmed Elhaddad, brand and marketing manager at MHE. He will guide us through securing digital battlegrounds with intelligent cyber defense and managed resilience. Thanks, Ahmed. Okay.
Thank you, Shah.
Okay.
Okay. Good morning, everyone. Thank you for joining this session. I hope I'll be able to deliver some valuable learnings through my experience with MHE. Let me start by introducing myself. My name is Ahmed. I graduated from Management Information Systems. That was my academic background. I did have some additional academic background in mechanical engineering, and that rooted from my passion for automotives. After graduating, I started working as an automotive journalist. I had a passion for photography and everything mechanical, everything cars. So I would join some publications to go and test drive some cars, take some photos of them, and write some articles, write some technical info about the mechanical systems, some smart digital systems that control the cars from ABS, ESP, and stuff like that. I worked for Al-Masri اليوم, الشروق, among some other publications, some of which you may not know, like Extreme Motoring and Motor Time. And in 2018, I joined InstaShop as a community manager, and I made my way up the marketing department until I became the head of marketing in 2019. And from then onwards, I started building my skills towards digital product building, as well as digital marketing in general. But without further ado, let me jump into the presentation. I will start. The presentation is split into 3 parts. The first part, I will be talking quickly about MHE. And then I'll be telling you how, I'll tell you a brief story about cloud technology and what it was like 15 years ago, and how applications started shifting from being premise hosted or hosted in a data center of a certain organization before the cloud migration revolution. In the second part, I'll tell you some problems that happened in the cybersecurity industry that accelerated the ecosystem and inspired most technology providers to adopt what's called a cloud-first approach. And then finally, the AI part I will share with you how after moving to the cloud, after the gradual move to the cloud that happened in cybersecurity service providers, AI started playing a huge and a very important role, and why that change was invoked in the first place, and how adversaries or cyber attackers use artificial intelligence to target individuals like yourself and myself. And on the flip side, how the technology providers are adapting their technologies to start fighting AI-based attacks. So MHE started in 2007, and we started as what we called back then a system integrator. A system integrator was basically a cybersecurity or a digital IT boutique, if you may say. You as a client or as a user would sit with the technical team and you would tell them, okay, I have the following vision for my company or for my organization. and I would like to implement those systems. And our technical team would start doing their homework in terms of procurement, how to configure the devices, how to connect the devices together, and how to integrate them seamlessly, so all the systems would work together without any issues or bottlenecks in terms of performance or in terms of security. The industry back then was vendor focused. So someone would come and they would tell you, okay, I want to buy Fortinet, for example. They have the chance to scan the market and check who are the partners in the market, and then they would email the partner, and tell them, please give me a quotation for that device. I would like to buy it. And they would gather quotations, and once they settle on a certain partner, probably for the most part, the partner's role was over. Very few partners would provide sound post-sales support in terms of technical consulting, in terms of troubleshooting or upgrades and updates and stuff like that. And that was because the vendors focused mainly on an ad hoc relationship with the client or the user who purchased the device or the service. In this model, or in this scenario that I just mentioned, the partner would be called a value-added reseller. So the value here being the configuration or the implementation of the system, and the reseller because they resell a technology or a device that another technology provider like Cisco or Fortinet or someone is providing. Okay. But the market is slowly shifting to a fresh model, a new model that was inspired by the cloud revolution, which is now called managed security services. Okay. In MHE, we try to be as dynamic as possible in adapting to the market changes and in the demands of the partners or the clients. So we started introducing our daughter brand. It's called Purple Guard. We founded the company in Dubai, and then we made another branch for it. We established another brand in Cairo. The core focus of the managed security services will be SOC as a service and XDR as a service, or managed X. And X here is a variable where you can just replace it with any security module or security solution that you will need for the future of securing digital infrastructure in terms of being AI ready, in terms of fighting AI-based attacks or behavioral-based attacks, which we will talk about in a bit. 1 second, please. Okay, Rahab, I'm not sure if the language for the okay. رحاب انا مش عارف بصراحه لو كل اللي هيجوين معانا هيبقوا مفيش حد مش بيتكلم عربي، خلاص هنتكلم عربي، ما عنديش مشكله. ممكن نعمل بول سريعا نشوف لو حابين اللانجوج تبقى عربي ولا انجلش. البول دلوقتي موجود عندكم. The poll is here now in the poll section. Please provide your answer, and if you would like me to continue in Arabic, I'm happy to do so. If you want us to stick to English, I'm okay with both. اوكي. انا شايف ان الاغلبيه دلوقتي بيفضلوا عربي، ف اوكي خلاص نتكلم عربي مفيش مشكله. اسهل واسهل. تمام، انا كنت بدي للموجودين دلوقتي نبذه سريعه عن MHE وهي بدات ازاي، وازاي بدات تتحول من فاليو ادد ريسيلر في الموديل الاولاني اللي كنت شرحته لان احنا نبقى مانج سكيورتي سيرفيسز بروفايدر. وده مش MHE بس، ده هتلاقي معظم الشركات اللي بتقدم سايبر سيكيورتي سولوشنز وسيرفيسز بتقدم السولوشنز بتاعتها دلوقتي بالطريقه اللي انا بحكي عليها دي. مانج سيكيورتي سيرفيسز معتمده بشكل كبير على الكلاود، وزي ما قلت من شويه هي الشيفت دوت حصل واحده واحده بسبب التغيير اللي حصل في نوعيه الاتاكس اللي بتحصل على الانفايرمنتس عموما او على الانديفيدوالز، مش يعني بتحصل على اشخاص او على شركات. هنتكلم الاول، يعني هديكم قصه سريعه عن الساس وكلاود ادوبشن، او ازاي الشركات بدات تتجه من ان هي بتبقى بتقدم الابلكيشن بتاعها على CD وانت تروح تعمل سيت اب للCD وتحط السيريال نمبر بتاعه او تحط البرودكت كي بتاعه علشان تقدر تشغله. وواحده واحده الموضوع تحول لان معظم الحاجات دلوقتي بتتقدم كلاود بيزد لاسباب ليها علاقه بالسكيورتي، لاسباب ليها علاقه بالانوفيشن. هو باختصار انت دلوقتي لما بتبقى، او يعني خلينا
Sorry
نرجع
for
15.
interruption, but we should speak in English because we have non-speaking Arabic. We have
Okay.
viewers from all over the world.
Okay, so I did okay, I asked the attendees earlier and we made a poll. But if this is if these are the rules for DSC, I guess unfortunately we need to stick to English. So Shahd, could you please check if we have any non-Arabic speakers in the audience at the moment?
Yes, we have.
Okay. Okay. Unfortunately, you guys, we have to continue talking in English. Sorry
Okay.
about that.
Okay. Thank you.
Okay. Okay. Sorry about that. Okay. So we'll start talking about. I'll give you a quick story about the cloud adoption and how inspiring it was for a lot of the cybersecurity solutions providers. So 15 years ago, I remember when an entrepreneur pitched some MVP, and they mentioned that their product is cloud native. This was a very attractive buzzword for investors to actually go ahead with the investment in the product. If we reflect this on what's happening today, probably AI and machine learning are as hot of buzzwords as cloud native was 15 years ago. And if we look at this from the viewpoint of an investor, we could totally see why this could be attractive, because cloud-based or cloud-native infrastructure means that there is a lower cost for implementation. There is a lower cost for upgrades, and you have global reach. You have a much faster product development life cycle. You can guarantee that the product users will receive the latest technology at no extra cost for their subscription or for their purchasing fee. And this, from an investor's viewpoint, it means that they will invest, let's say, less capital, and their operation cost will be a lot more optimized, and the return on investment will be much higher. Okay, and this is not out of greed. This is just basic cost engineering, because as an investor, you try to maximize your return on investment. So SaaS applications skyrocketed in the last 10 years, and we had a phenomenon that some people call data explosion, because most of the data is now internet hosted or cloud hosted. So you have it shared among many platforms. If I give a brief example about online advertising, for example, some some advertisers or some advertising platforms like Google Analytics and Facebook, like Google Ads and Facebook and whatnot, most of them share the advertising ID of the user or the individual who's using a certain who's accessing certain websites and accepting cookies. Um, and this would not have been made possible except if most of this data is cloud hosted. Of course, it could have happened with multiple other ways, but it would have been a lot slower. Some examples of services that were provided once on premise or physically were video on demand. So if you remember back in the time, if you wanted to watch a certain movie that was not available on TV, you had to go to a certain shop. You had to pay for a rental fee and get your movie or your tape, take it back home and put it in your VCR and start watching it. But now we have VOD platforms like Netflix and Shahid and Watch It. You basically pay a monthly subscription fee and you have a full library of movies and series to watch online. And if we look at the business domain, Microsoft Office, for example, also maybe 10 years ago, you had to buy a CD for Microsoft Office. That CD came with a product key. And with that product key, you could use the version of Office that you purchased for a certain amount of time until it's no longer in service or serviced by the technology provider, which is Microsoft in that case. And then you had to go and buy a new CD and install it again. Right now, you're using Office 365. You basically subscribe with your username or your email. You also pay a license fee, and you can use it for as long as you're still paying it. Adobe Creative Suite is probably the same story. I remember we had to go and get the CD from specific vendors. It was very hard to obtain, and you had to find someone who's an authorized Adobe reseller, and you had to put the product key. And then when they did an update, your version is no longer eligible for an update, and you don't get a discount for the later version. So you had to pay the full cost again if you want to upgrade to the newer version. But right now you have Adobe Creative Cloud. You basically subscribe one time, you pay a monthly subscription fee, and you go on with the updates. You can update periodically, like Adobe Creative Cloud on my machine, for example, or on my in my environment right now. I receive updates probably on a weekly basis at no additional cost. So to summarize this part, cloud has proved to be a very cost-efficient way for users and for investors alike, and for technology providers. It enabled for much faster updates. It enabled for seamless pushing of new technology without the user being affected and without any downtime. And this was a very inspiring story that I believe cybersecurity technology providers did lose a lot of their market because they had not adopted this earlier. But we will see why this was actually there was a good reason for that. If you've dealt with any cybersecurity professionals before, they're usually more on the paranoid side. They like everything to be on premise. They like to have the device under their control whenever there is an issue, whenever there is some troubleshooting needed or something. They needed the device in front of them, so they could guarantee that they would have a direct connection to access the back end of the technology and or the device that they have or the appliance. To push any updates or to do any configuration that may be needed. So if we look at how you would purchase a cybersecurity appliance 10 years ago, you would go to a certified partner or a certified reseller, and you would buy the device, and you would use it for maybe 3 to 5 years before the vendor announces a new update or a new model for the same function or the same use case. But you get that after a lot of work that has been done from the vendor's side. This work, we could talk a little bit about. I'm really sorry, Rahab, but I can read the chat and I can see that you are having a problem with me speaking in English. I have to stick to the rules of DSC because this is a global event. But I'm happy to redo the presentation in another time in Arabic outside of DSC. So let's get back to the product development life cycle. If we put ourselves in the technology vendor's shoes for some time, before you release a product to the market, you have to go through the product development life cycle, which we will abstract it into 4 phases. There are actually 5 phases, but there is one that we will talk about very briefly, so I didn't add it in the presentation here. The first phase is the pre-launch, and this is usually the phase where the vendor or the manufacturer will do the research. They will start doing some focus groups, some interviews with the users, gauge the demand of the market, assign some market research organization to check where the demand is highest on certain use cases or certain devices. And then from the results that they get from the research, they would move to the ideation phase, where they would start thinking internally, okay, how would we tackle these demands or these problems by doing 1, 2, and 3, and they would start drawing a roadmap for how to start the development and prototyping of the product. This phase depends on how deep of a pocket the technology vendor has, and they could consume a lot of resources. And in that case, usually it would take between 6 to 12 months to come out with a prototype and start testing it. Once the testing is done and the use cases are validated and the stress tests and the quality assurance tests are concluded, the technology provider would then move to the manufacturing phase in parallel with the go-to-market planning. Okay, so manufacturing takes a lot of time because you have hardware that needs to be manufactured and needs to be produced. They need to find the factories for the circuit boards, for the housing, for the plastic parts, for the accessories. While the marketing department starts planning the launch of the product and the go-to-market plan, and they start assigning distributors, they start sorting out logistics. Once that is concluded, we go to the service life phase. The service life is basically once the product starts being delivered to users. Okay, so in case of the Egyptian market, for example, there are no communication devices that get manufactured locally. So the ecosystem looks something like this. You have the technology provider who is headquartered in the States, for example, or in Europe, and they manufacture in China. They have a local or a regional distributor in Gulf area or in Egypt. And then they have their target market, which could be regional or it could be local, like in Egypt, for example. A user or a client who requests a device in Egypt would communicate with a distributor, would communicate with a partner, the partner would communicate with the distributor. The distributor would place the order, which will be shipped overseas and stored. You have to do the custom clearance, and then you receive it at the partner's premises, and the partner would then deliver it to the user. So as you can imagine, this is a very lengthy cycle. One second, please. Okay. Sorry about the pause. So during the normal years, like since we started MHE in 2007, all the way to 2018, we have never faced any issues with shipping and logistics, with replacing a device under RMA agreements with partners. But in COVID, this product development lifecycle started showing how it had a single point of failure, particularly in production. And this will be the first problem that caused cybersecurity vendors or technology vendors to start thinking, okay, we need to change the way we provide our services. The biggest issue, which is logistics, that was caused because of COVID. Some silicon wafer factories had to shut down. Production was extremely delayed. Hardware production was affected. And in our case, like for example, at MHE, I remember that we had some requests for certain devices that were back ordered, and we had to wait up to 400 days to get the device. So when we sat with the client and we told them, okay, you have to wait a year, over a year, to receive your device. I imagine if had it not been for a global issue, COVID, this would have lost us a lot of market as a partner or as a reseller. But luckily, it was a global issue and everyone understood back then. But this issue caused the technology providers to start thinking in alternative ways to provide their services or deliver them to the clients without by evading this critical path of production. I believe there are two more reasons that encouraged cybersecurity vendors to start adopting the cloud-first approach. One of them is obvious to some people, and the other one might only be obvious to people working specifically in cybersecurity. So the second one was the innovation race. Maybe as a technology provider, as a technology reseller, we didn't really, we were out of touch in this part. But if you read some stories about vendors that lost market share because they weren't prepared enough for the cloud adoption, or they lost the innovation race, basically. And when I tried to dive deeper into the reasons why they lost the innovation race, it was mostly because they weren't prepared enough for the cloud-first approach. FireEye is one example of that, but the most obvious example, or the most easy to understand example, is Riverbed. This is a technology provider that provided WAN devices or WAN services. Their WAN is for wide area network, and these were devices that allowed an organization to connect two separate sites, like let's say one in Cairo and another in Alexandria. They have no physical connection. You could implement a WAN solution that created a virtual tunnel, and that virtual tunnel would tell both networks we are one. Okay, they would operate as if they are one network. From WAN started, there was something that started. Sorry. I'm not sure if you can see it in full screen now or not. Okay, if I do it in full screen, unfortunately, I lose the view to the chat, so I have to keep it boxed for now. Okay, so sorry about that. As I was speaking about Riverbed. So Riverbed provided as a WAN technology provider, and around 2014 or 2015, the term SD-WAN or software-defined WAN started emerging in the market, and it depended one way or another on cloud technology, in the sense that a software would start communicating from a device in one location or on one site to a cloud-based service. The tunnel that I spoke of earlier would have to go through a cloud service first before making it to the second site, and slowly you could do that without devices on premise at all. So you could do that through a firewall, for example, not specifically through the steelhead device that Riverbed provided. Riverbed did not adapt to the cloud revolution, and in 2021 they had to file for bankruptcy. And unfortunately, they ceased to exist as a provider in the market. The third problem that I believe started making waves in the market and accelerated how cybersecurity services are being provided was the knowledge density and the talent gap. But before I jump into that, I need to add something real quick. So if you're familiar with firewalls, for example, at maybe also around the 2014, 2013, you started hearing the term sandbox. And sandbox was basically a fancy word for a cloud-based AI engine. And it mainly focused on scanning threats or certain types of attacks that needed vast processing bandwidth that was never possible through client available hardware. Which means that if you purchase a firewall, for example, the firewall would have a certain processing bandwidth or a certain throughput for scanning the traffic before it makes it into your network. And if a file or if a certain service is too big to be scanned, or if you put it into the engine that you have on premise, it would cause a lot of delays. Then the technology provider had a script that would redirect that traffic to a cloud-based sandbox. This would run on a cloud service, validate if it's okay or not, and then it would go back to your network if it's not harmful or it's not a threat. And this was the first step for cybersecurity providers into cloud-based services. So this was only made available because the provider could not charge the user for a huge processor, while the user just needs this much bandwidth or processing bandwidth or throughput. Okay, so this is how the sandbox came into life or was made available to users. And it was the first step into cloud-based and AI-based cybersecurity solutions. The other problem, which was very obvious to us as a vendor agnostic reseller, as we like to call ourselves, the knowledge density and the talent gap. So the talent gap is very obvious in the cybersecurity market. You can hear about it globally in any market, not just in Egypt. There's a statistic in this presentation later on where we will show that there's around 3.4 million jobs that are looking for individuals in cybersecurity. And I believe this could have something to do with how deeply vertical this domain is. The specialization in cybersecurity is quite diverse. So you, as a fresh graduate or as someone who's still stepping into cybersecurity, you probably find yourself reluctant to pick a certain track and stick to it for a few years before deciding whether or not you want to switch to a different track. And when you stick to a certain track, there are some certifications and some vendor specific certifications or industry specific certifications that you need to acquire just to present when you try to apply for another job. It acts as a validator for the kind of knowledge that you have, and it tells the person hiring you that you have the required skill to fulfill the job that they need. On the other hand, the knowledge density part, by knowledge density, we mean that there are two parts when it comes to technical systems. If we look at programming, for example, there is logic and there's syntax. If you understand the logic of the machine, this is perfect, but you need to understand the syntax of the language that you're speaking in to implement that logic or to apply that logic. The same would apply on cybersecurity. So if you understand what intrusion prevention means, for example, this is great. But to understand how to implement intrusion prevention using a product X or product Y or solution Z, you need to acquire some extra learning. So you would usually find an argument about working independently versus working or working client side versus working agency side. Working client side would always give you very good horizontal knowledge. You would have vertical knowledge. You would have a very deep understanding of the environment you're in. But working agency side would give you a more broad overview about different syntaxes, if I may say, about different use cases, and eventually you start focusing on how to get the job done without sticking to a certain syntax or without sticking to a certain language that only one vendor speaks. And from here, we can move on to how slowly technology vendors started realizing the knowledge density part and started realizing that, okay, the channels that I'm selling through are people who actually understand my system fully. They understand the competencies that I have in my solution. They understand my competitive advantage. And this would make them the most eligible to say or to attest in a certain environment, okay, this solution would be the best for that use case, okay? And in the sense of being vendor agnostic or not having prejudice towards a certain vendor, this means that you can orchestrate a system from multiple vendors and present a solution that would fit all the use cases of a certain environment without having bias towards a certain brand. So what does this translate to in real life? Like, why are we getting too deep into why the partner vendor relationship and the client and stuff? 1 second, I'll take a look at the chat. Sorry. Okay, so it seems that Yasmin is handling the debate that's happening over here. That's great. So my sole purpose from jumping into this part or from diving this deep into this part is because I will show you later how organizations will not have to expend a lot of capital, whether it's in recruitment or in technology or whatnot, to achieve a robust cybersecurity posture. And this could only be possible through cloud-based services, through artificial intelligence, and through the newer model that's called managed services. Okay. I'll give you an example about a cloud-based service that is email security. Again, in the traditional sense, you had to purchase a virtual box and install it in your data center. You had to configure it and make sure it's well integrated with the rest of your technology portfolio, let's say. So here, the first thing you did, you paid a lot of money to purchase that device. Okay. The second part is that you have to license that device periodically. So every year, for example, you have to buy a new license, or every 3 years, to make sure that the services are active and you're receiving the security services that you opted for in the first place. And the third part is that the implementation could be complex in terms of cabling, in terms of configuration, in terms of having it integrated with multiple other devices, in terms of your LAN structure. All of these were challenges at the time. As opposed to now, you can get a cloud-based cybersecurity service, email security gateway. In our case here, I'm talking about Barracuda, for example. Barracuda Networks provides email security as a service. So it's a cloud-based service. If you're using Microsoft 365 or Google Workspace, which 80 to 90% of workspaces are using today, you simply, in non-technical terms, it's as if you're connecting an API connection between Barracuda's cloud and Microsoft's cloud. And you, as a client or as a tenant, when you receive an email, it's automatically scanned. The AI checks for any anomalies in the email address. It does the natural language processing to see whether this email is a phishing email or is a safe email. And once it's been deemed safe by the security gateway, it makes it to your email service provider's cloud, and eventually to your user's mailbox. So this reduces your capital expenses. You don't have to buy a device in the beginning. You leveraged AI at no cost from your side. You leverage machine learning because as your operations are going, the email security gateway is learning about your environment, learning the language of your employees, and learning how they're typing. They start building a personal profile for each professional or for each team member, with the goal being to avoid any impersonation. If someone tries to mimic someone's voice or someone's tone in writing an email, the AI engine would immediately detect that, and it would deem this email unsafe and block it from making it to the mailbox. The same story applies for other security solutions like web application firewalls. Again, right now, most relevant businesses have their services cloud-based or cloud-hosted. So you need to secure that still because of the shared responsibility model, which unfortunately we don't have the time to talk about in this presentation. But I'll mention it briefly. When you host your application online, there is a shared responsibility in terms of security. So let's say you go for AWS, or you go for Google Cloud, or you go for Microsoft, whichever vendor or cloud vendor that you opt for, there is a shared responsibility in terms of security. So they're bound by contract to secure certain elements of the cloud, but beyond that, it's your responsibility. And it depends whether you're taking infrastructure as a service or platform as a service. Each one of them has a different security model. But at the end of the day, you cannot blame Microsoft, for example, because your cloud-hosted application was attacked, or there was a breach, or there was a certain DDoS attack on one of your services, or whatever, any kind of threat that emerges on your online application could be your responsibility and not necessarily the cloud providers. So let's get back. If you have a cloud hosted application, it's much easier for you to get a lot of security solutions today, and you'd be leveraging AI because by being cloud hosted, this means that you have ample resources for processing, you have a huge bandwidth, you have almost 100% uptime, and this is because the vendor cares about their reputation first and foremost. And that reputation comes from having a robust infrastructure and providing the clients with, or the users with the technology that keeps their product going for as long as possible without any interruptions. All of these reasons that I just mentioned makes cloud first a very obvious solution for cybersecurity vendors to start providing their services online instead of providing them as hardware-based solutions. But probably the most or the fastest emerging issue that made everyone who says cybersecurity change to cloud-based provisioning is the rise of AI attacks. As I mentioned earlier, AI is synonymous with huge processing bandwidth. It's synonymous with very high speed, very high scale. So when we mention this in the domain of threats or cyber attacks, this could make it very scary. Like if you think about it, for each cyber defender, or let's say, or for each cybersecurity individual now, you have at least 100 AI-based cyber attacks that are targeting this individual, and they need to have the right shields and the right protection measures to defend against this. So if we look at what a security operations center is, or if we look on an enterprise level, usually enterprises right now split their teams into multiple phases. And in cybersecurity, they have very attractive colors for them. You have the red team, you have the purple team, and you have the blue team. And you have the black team in the end. So the red team is usually concerned with what's called offensive security. And when we say red teaming, we think penetration testing or stress testing. And this is basically, in a sense, friendly fires, or the part of the team that goes into your online presence, goes around your technology landscape, and try to find ways to make it into your network without being detected. They try to make it to the mission critical assets. They wear the hat of a hacker basically, but they're your friend. They're doing this basically to try to find the vulnerabilities in your network, or the entryways that the hacker could leverage to make it into your network. In red teaming at the moment, it's quite easy to leverage AI tools. Network scanners and vulnerability scanners right now can be leveraged very easily by hackers to scan a certain environment and find the entryways to that network. Could you recommend some cloud platforms that does not belong to big companies like Amazon? Okay, Alexa, I will reply later to your question. So I'll just finish this section about the teams, and I will let you know. as I was saying, the red team is the offensive team, or the team that does offensive security. They try to find entryways through your network to make it to your mission critical assets. And once they find a valid way, they add it to their findings, and they provide these learnings to the purple team. The purple team usually gets their information from the red team, and they start preparing on how to defend against such threats. Start patching these vulnerabilities so that you don't receive any similar attacks in the future. And then you have the blue team, which does defensive security. Let's say they have some frameworks to work with, like NIST, like MITRE ATT&CK, like CIS, some frameworks that are very known, and some of them are industry specific. Like MITRE, for example, has some manuals for online payment gateways. They have some for healthcare, if you need to be HIPAA compliant or something like that. You need to follow a certain framework. And eventually the black team, this is the response team, your response team that starts dealing with the environment post-infection. And this is from a very high level. But if we dive deeper into what a security operations center ideally looks like, I have to answer Alexa's question quickly. So sorry, Alexa. I know a couple of cloud providers in Egypt. I'm not aware of other providers, other global providers. But there is, for example, GDX, there is Raya Cloud, there is Link Data Center. All of these are great cloud platforms available in Egypt. They have POPs worldwide, so you might want to Google that to check if their services are available in your location. So getting back to this, let's take a look at what a modern security operations center looks like. But before I talk about that, I'll give you also a brief overview of what there's a very famous framework for cyber attackers called the kill chain attack. And this kind of attack usually is implemented to gain access to a big environment or an important environment through just one individual. So let's say, for example, you're working for an important university, or you're working for a big company, and someone found that out, and they want to start targeting you, not you personally, but they want to target the environment you're working in. They can do this through you. Okay. The stages of this attack usually start with what's called reconnaissance, and reconnaissance is the phase of gathering information. They scan the dark web for data marketplaces or for email marketplaces, and the end goal is to find emails that are valid, or find user accounts that are actually valid. And in this phase, they can use a tool that's available now called Maltego, for example. And this automates footprinting by linking emails and domains to social profiles. So through an AI tool, they would gather emails or get emails from the dark web, from forums, from marketplaces on the dark web as well. And they would leverage both these tools to link emails with your social profile. So from your email, they would find your LinkedIn account, they would find your Facebook account and Twitter account, or Instagram, whatever. Usually or traditionally, this was done through something called open source intelligence, and it took a lot of time. But with AI, this process could take as little as 5 minutes. Okay, and then from there, they can actually start targeting you in phase 2, which is called weaponization. They would create a payload, which they could also create using AI. instead of targeting you with a malware that is a static file or an infected file, they would do a polymorphic malware, and this is the type of malware that changes its code every time it targets the same environment. So, for example, I targeted you this time, and I evaded the security solution. The AI engine would then retrieve the file again, change part of the code, and then retarget the same environment. So this is not detectable as a DOS attack, for example. And at the same time, it would not be detectable by any security solution simply because each time the file is different. Once the weaponization is successful, they could use tools like Fraud GPT or Poison GPT to create phishing emails that are undetectable by non-AI based email security gateways. And once they make it into your mailbox, and they understand your behavior from earlier, from targeting you online or from the reconnaissance phase, the tool would then be deployed into your machine, and this would start, or would give them the leverage to start what's called the exploitation phase or the lateral move. So in that phase, once the attacker or the cyber attacker makes it to your environment, they can then use AI-based network scanners as well to check for vulnerabilities within your environment, within your network, to check for database like account databases with their credentials and with their privileges, to understand who has admin privileges, and they could use some AI-based scanners or AI-based tools to give priority to accounts that have higher privileges in the network. And after that, they would start installing their rootkit, or start installing their payload onto the machines and gain access over the full environment. All of these phases, unless you have an AI-based tool for defense, you're basically infected in no time, or your environment would be infected in no time. And this is why we keep stressing on how important it is to start adopting AI-based cybersecurity tools, because attackers have access to all of this. Some of them are even free tools. Some of them can be leveraged against individuals and against organizations. And it could result in ransomware attacks. It could result in data theft. It could result in the worst case scenario, which is a complete shutdown of your services if you're not careful enough. How would you prepare for that? This is when we look at ideally what a security operations center should look like. A security operations center is divided into 5 major pillars. The first one is the monitoring and detection pillar. And this is the analysts who make sure that they are always watching what's happening within your threat landscape. They're checking with behavior-based tools and AI-based tools whether there is a service that's being activated on one device and then another payload that's being deployed on a certain device, or someone who's trying to sniff a port of a certain firewall or a certain security device. You as an individual had view over a dashboard back in the day for a certain device, like a very specific device, but you couldn't have visibility over the entire landscape or your entire portfolio all at once. And this is because you just won't, like the change of context that you have to do would make you lose focus very quickly, and it would be very challenging to just feed your brain information in parallel from multiple devices all at once and then take action, because by the time you reach device 5, for example, the information that you gained from the logs of device 1 could be changed. Okay, So here you have a lot of tools available today for monitoring and detection, whether on the endpoint level, like the user's devices, whether they're connected to the network or not. And this is thanks to being cloud hosted or having a cloud-based service. I'll give you a quick example on an EDR solution, endpoint detection and response solution from Kaspersky, for example. This is independent of whether or not this device is connected to your network. You have an agent, a small agent that is installed on the device, and this agent is constantly communicating with a cloud engine, a cloud-based engine for Kaspersky. And if there is any behavioral-based attack, so if the attacker, for example, as we said earlier, started trying to do lateral moves through your device or started to activate a certain service that is not within your normal day-to-day operation, there would be immediate intervention even before the user finds out. So this is in terms of monitoring and detection. And then you have threat intelligence. So threat intel is basically a proactive and like a predictive part of the security operations center. At this time, they leverage AI tools to AI and machine learning at the same time to start gaining information and data from publicly available data about behavioral-based attacks, and then feed it to their threat library about frameworks like NIST and MITRE that I mentioned earlier, and feed it to their library. And then there are internal threat intel, which scans the internal network, because sometimes the malicious actor or the adversary is actually within your network and not an external threat. So in the sense that, for example, let's say that your team member X is not very aware in terms of cybersecurity, and they're very gullible in the sense that if someone sends them a message with a link, they wouldn't check the source of the link. They wouldn't check if that's actually the person who is eligible to send that message. Or they would receive a USB drive from someone outside of the company, and he would ask them, "Oh, please just copy this file onto your machine," and they would do this in all good faith without understanding like the consequences that could happen from such actions. So this is what we mean by internal threat. So the threat intelligence team is in a constant state of research, in a constant state of learning to expand the internal library of the SOC team with the goal of understanding previous threats and preparing for future threats that may occur. The third part is the incident response team. So let's say that, God forbid, you did face a threat, or you have a ransomware attack, or one of your accounts got taken over by an adversary or by an attacker. This is when the incident response team starts their job. They would start trying to remediate that action. They would have playbooks that say, okay, if someone's account is taken over, we do 1, 2, 3, 4. We cancel their access on these assets. We start creating a new user with certain privileges. We take more security. We put more security into action for that account, like enabling multi-factor authentication, for example, or disabling access from outside the network, and so on and so forth. Okay, the security engineering team. This is the team that is always concerned with continuously upgrading the configuration of your infrastructure and your technology portfolio in terms of the SIEM or the XDR devices, and developing the tools that they're using and the vulnerability management. So what is SIEM and what is XDR? SIEM is the security incident and event management software. You could think of it as your the head of your security guards. They're constantly gathering information from multiple data points around your network in logs. Okay, so every device produces logs for any changes that happen. Whether this change is someone gaining access, someone changing a file, or something as simple as an IP speaking to one device and then redirected to another device. All of these are data that is available on your network through logs. Okay, so a SIEM or an XDR device, they collect logs from your environment, and the security engineer's job here is to start to correlate these logs together to build certain cases. So they would say that if you get this log from that device plus that log from this device and finally this log on that machine, if these three occur within a certain time frame, alert me with that alert, okay, or give me alert X. Because the human knows that this kind of correlation means that someone is trying, for example, to learn about your account privileges, or they're trying to know which ports are available on your firewall and are open and unused. Okay. So XDR does a very similar job, but in a different operation scheme. But we'll not dive into it deeply because the whole point is to give you an overview about the Security Operations Center, and we'll show you later how artificial intelligence is helping all these team members expedite their operations a lot, and start freeing their mind to more strategic actions or more strategic thinking. Finally, you have compliance and reporting. Compliance is not something that all organizations need to stick with, but it's a very daunting task, and the margin for human error in this is very big. Two very important or two very obvious parts are healthcare sectors. Sorry, excuse me. Or healthcare and online payments. So in healthcare, you have if you're a healthcare provider and you have online assets or web-based assets, you have personal information, you have information about infections that are associated with certain accounts on your database, and this is very valuable data to attackers. So you have to do you have to get a HIPAA compliance and an ISO 27001, I believe. And these are certificates that tell technology providers that, okay, this environment has deployed all the right measures to keep their patient data safe. And in terms of fintech, for example, you get PCI DSS compliance, which says, okay, this payment gateway has deployed all the needed security measures to protect their clients' financial data. So if you think of this on the scale of the environment, the task could be very daunting for you to scan the full network, to find the vulnerabilities, to find entryways for attackers to gain access to such information. And if you leave room for the human error, you're basically risking your full brand. So the question is now, do you think that every company has the capacity to implement a team this large? So if I look at this quickly, this is at least 15 people without the SOC director. If we say that you will have one professional in each domain, do you think that this is something that is feasible for all organizations of all sizes? This is a question, you guys. Okay, so obviously this is I trust that you guys understand, but yeah, of course, obviously this is not very feasible for all organizations, and this is the reason why managed services has started emerging in the market, and along with AI, um, it could amplify the capabilities of each organization, regardless of how much resources they have to they're able to invest within their security teams. So managed services or getting a security operations center as a service would help you tackle these issues because, as I mentioned earlier, technology vendors are now relying more on their channels and their partners to implement the solutions and to manage the day-to-day operations after implementation. Because, as I said, they have higher knowledge density. They understand more what could be done in certain environments and in certain use cases. So they would be able to script the AI-based solutions much more efficiently to serve that organization best and to tighten the security posture of that organization best. Again, AI-based cyber attacks have grown 300% year over year between 23 and 24. All organizations of all sizes, at least the ones who have web-based or web-hosted services, will need at one point or another to start preparing for this threat that's coming. And at the same time, this doesn't cancel the need to hire professionals or the need to start training for cybersecurity or the need to start gaining more experience on how to use AI in a smarter way to amplify your defenses and your shields. Okay. AI is not replacing humans in the domains of cybersecurity, but it's those who have the ability to deploy AI in a smart way that will be able to amplify their defenses significantly. So if we start thinking about what's the most optimal setup for, let's say, 2030, if you want to start preparing now, you want to orchestrate a human and an AI team. In the terms of you need to start thinking that humans will be responsible for the strategic thinking, will be responsible for the ethics and the context and creatively tackling some problems, while AI will be the engine that they deploy to speed up and scale their operations. The optimal solution, from my point of view, would be managed services that leverage AI plus a human team. Like, this combination would be the winning combination in the future. So if you're working for company X and you are responsible for cybersecurity, you do not need to start thinking about your team and how you will hire 15 people to operate. But instead, you will start thinking, okay, who's the best service provider in terms of web application security? Who's the best provider in terms of email security? And you'll find partners who are able to provide you with these services in a managed form. Managed basically being the sense of, if you're familiar with marketing agencies, for example, they call it a retainer. Okay, so you basically partner up with the agency and you give them the direction. Okay, I want my messaging to be X, Y, and Z for the upcoming 6 months. And the agency will do all the daunting work of content creation, of A/B testing, of stuff like that, and they would come to you with the result of their learnings. Okay, so if we reflect this on the cybersecurity industry, this is exactly the same. A managed security service provider has been testing their tools. They've been deploying similar solutions in similar environments to yours. And they've been practicing this for a long time. They know how to leverage AI in your environment, for example, to give you the best operational efficiency. And at the same time, you won't have to let's say, waste your day-to-day in daunting tasks that an AI engine can take over. Like if we go back to the slide of the SOC Operations Center, as I told you, here in vulnerability management, for example, part of this is vulnerability scanning. This is a very resource-heavy process that requires multiple machines to operate on multiple areas of your network for a long time, just to know where the vulnerability might come from or where the vulnerability exists. To conclude my talk, basically deploying an AI-based solutions, leveraging the knowledge density in managed services providers who are available globally, by the way. You don't have to stick to a certain managed service provider. You can deploy multiple providers for multiple services, along with a strategic human vision, would make you very well prepared for the AI threats that may be emerging in the market at a very fast rate. I hope that my talk has given you a deep insight on, or a valuable insight on how AI would help tackle AI attacks in the future. And I would like to hear if anyone has any questions. I'm happy to answer. But I need to give you heads up that I'm not a very technically well-versed professional. My responsibilities are more concerned with the business side of cybersecurity. But again, without further, if you have any questions, please feel free to ask. Thank you, Nancy. Okay. Thank you guys so much for attending. I hope the session has been valuable for you or added some knowledge to you. Please, if you would like to follow our page on LinkedIn, do so, because I'm sticking to my promise in representing that presentation in Arabic for non-English speakers. And I will be announcing that on the page's LinkedIn account very soon. Thank you, Saif.
Thank you, Ahmed. We'll take a quick break. See you right after.